second function, right? What is that? Minus cosine t dt. So this looks a little bit crazy, but that's the way you do. How did you do the by parts? Did you put the first function e minus st?
I did integration by parts again on the
Yes.
other integral.
So
that will get you something times the sine of t, then you just put sine.
So minus minus plus e minus st cosine t dt. Now you take another one. So it will be e minus st. So integral is sine t minus e minus st derivative and sine t, right? First function, and you have sine t dt, no, cosine t dt. And then you simplify that, there will be a function, this will be minus sine t, you take it on the other side and then solve it. Right? So this is the, so you solve this, and you will see that there will be a function minus sine t appears on right hand side, you move it to the left hand side. You move to left hand side. You move to left side. And when you move to left side, you already have e minus t sine t. So which means that you simplify it by taking this common and then take the coefficient back here, and that will be your answer. So I believe that this is really something which we should do. It is important that you do really integral of these things, okay, and solve them. So it's not difficult, but the question is that although these things will not appear in exam, you will use the chart. There is a chart which tells you what is Laplace of 1, Laplace of t, Laplace of sine t, Laplace of cosine t, Laplace of sine hyperbolic t, Laplace of cosine hyperbolic t, Laplace of et, e power at into t, and so on. So these are the couple of things which you should really remember. These things are just the practice. I put the table here, which I think I already had a table which I told you. So what you do here, you will see twice you do integration by parts. That's what you have to do. And then you will find out its limit. Now remember that this class is not linear algebra, so I cannot spend time on Laplace, but I just give you few hints that how you will do that. What is more important is the table, and that table is what I want you to pay attention. So we already have, these are the basic one, that the Laplace of t power n is equal to n factorial over s power n plus 1, where n may be equal to 1, 2, and so on. The Laplace of sine kt should be equal to k over s square plus k square. Similarly, Laplace of cos kt should be s over s square minus k square. And then you have plus k square. And then you have hyperbolic functions which may appear. So you have sine hyperbolic kt, and that will be same as your sign, except it will be negative in the denominator. And cosine hyperbolic kt will be equal to s over s square minus k square. Then if you have a function of u t minus, let's say, a, then its Laplace is e power minus as over s. And if you have Laplace of, that's it. I think these are enough for you to remember. Once you have done that, then one thing which is important is how to do the inverse Laplace, and that's what we will try today, because I think that is okay. So how would you like to do inverse of, let's say you get the function which is this one. How would you like to do it? How you will take the inverse Laplace?
You split it?
You split it. The first thing is you split it. So make sure that you split it properly. So you will get minus 2s inverse Laplace over s square plus 4, and then inverse Laplace 6 over s square plus 4. When you split them, please be careful. When you split them, what is in the denominator is s square plus a constant, which can be written as s square plus a constant square with plus sign. Then this is the one actually you are looking, right? Because in the numerator there is just a constant, you can multiply and divide the term by that particular constant. That k should be the same as k square. So here I will take minus 2 outside, and I will say s over s square plus 2 square. Here I will take 6 outside, and I will multiply it by 2, and I'll put s square plus 2 square, and I'll divide it by 2 as well. So really I manipulated my fractions. So if you pay attention and you see how this inverse was done, you will see that you have minus 2, which is this one, s over s square plus 2 square, then s square plus 2 square, you multiply by 2, you divide by 2, and take your constant out. Now anybody can tell me what is the inverse of s